After water, sand is the second most consumed natural resource on Earth. It is the physical backbone of modern civilization, though it remains almost entirely invisible to the people who use it. Look at the material poured into these forms. Concrete and asphalt are essentially massive quantities of sand and gravel held together by a binder, forming the core of every hospital, bridge, and high-rise on the planet. In these precision laser environments, highly refined silica sand provides the raw input for silicon microchips and glass screens. This specific grade of sand is what makes the microprocessors in our smartphones and computers possible. Modern human development is built on a resource we rarely notice, and because we consume over 40 billion tons of it every year, the supply is reaching a breaking point. It is difficult to visualize a shortage when sand covers the Sahara and the Arabian Peninsula. If these vast deserts exist, the idea of running out seems like a contradiction. The desert sand is physically unusable for construction. Centuries of wind erosion polish these grains until they are perfectly round and smooth. If you mix them into concrete, they simply slide past each other under pressure, failing to hold any weight. Stable infrastructure requires aquatic sand found in rivers and oceans. These grains have jagged, angular edges that interlock like puzzle pieces, creating the rigid internal structure needed to make concrete solid. Because only these specific water-shaped grains can be used for building, our global supply is restricted to the specific, localized riverbeds and coastlines that produce them. Rapid urbanization drives a demand that natural geological processes cannot match. A city like Shanghai has added millions of residents and more high-rises than New York City in just 2 decades, all of which require massive volumes of aquatic sand. To meet these quotas, industrial dredgers act as a giant underwater vacuum. They lower suction pipes to the floor of lakes and oceans, pumping up millions of tons of sediment and blasting the heavy slurry into transport barges. This process strips the life out of aquatic ecosystems. It destroys the breeding grounds for fish, suffocates underwater vegetation with sediment plumes, and permanently alters the chemistry of the water. Removing this sediment also destabilizes the land above. In several countries, vacuuming riverbeds has caused bridge foundations to fail and riverbanks to collapse, sending houses sliding into the water. The very act of expanding our cities is physically dismantling the riverbeds and coastlines that protect our communities. Nations now use sand to manufacture new land. By dredging and pouring millions of tons into the ocean, governments are engineering massive archipelagos to push their sovereign borders further into the sea. This aggressive expansion has triggered international conflict. Massive reclamation projects in one country have been linked to the disappearance of islands in neighboring territories, leading to strict export bans and diplomatic standoffs. When legal supplies are cut off and demand remains high, violent black markets emerge. In several countries, criminal syndicates known as sand mafias have taken control of the supply, using force to steal the material from protected areas. These illegal operations use heavy machinery to aggressively tear into riverbeds, bypassing all environmental protections. They ruin local fishing grounds and destroy the livelihoods of farming communities to feed the construction boom. This scarcity has transformed an ordinary material into a strategic asset that fuels geopolitical tension and organized crime. We are facing a structural crisis: how to provide housing and infrastructure for billions of people without permanently destroying the aquatic ecosystems that keep our coastlines stable. Solving this requires a move toward engineered alternatives. One solution is M-sand, or manufactured sand, which uses machines to crush hard rocks into the specific angular shapes needed to bind concrete, completely removing the need to mine natural rivers. Another emerging technology is ore sand. Inside this industrial processing equipment, mining companies are beginning to extract usable construction aggregate from hazardous mine waste, turning a dangerous liability into a sustainable resource. We are also seeing the rise of circular economy initiatives, where millions of discarded glass bottles are ground back down into sand. This recycled glass is used for both concrete production and restoring eroded beaches. The global sand crisis proves that every building we raise has a physical cost. We must shift towards sustainable engineering now, or the vital riverbeds and pristine coastal beaches that protect our world will simply continue to vanish, grain by grain.